Very good morning to you.
Right, okay. No.
So this is the first day school for EEX3417, Software Development for Engineers. I am Professor Udita Ratnayaka. I am one of the academic coordinators for this course. Mr. Neil Herat is the main academic coordinator and the course coordinator for this course. And other than two of us, there are other senior lecturers like Dr. Ajit Madhurapperuma and Dr. Menaka Ranasinghe, who may come and do day schools and do other assessment for this course, since this is the course offered to all students who have registered for BTech engineering. Let us start today's day school. These are few guidelines since we are delivering the day schools online. When you come to participate the day school online, please adhere to these guidelines. Change the name to your actual name so we know that you participated, and if you are going to ask a question, then we can ask a question from your name. Keep your microphones muted unless you are asking a question or that you are going to answer a question asked by the lecturer. And if you want to ask a question, please raise your hand. You can post your questions in the chat box when the lecturer asks you. Please don't keep posting questions in the chat box all the time. When I am delivering this lecture and talking to you, I will not be always looking at the chat box. So I will definitely not answer all your questions. So please wait until the question answer time to post your questions. If you're not going to unmute and ask, and if you like to post your question in the chat box, wait till the question answer time and then ask. Because as you see, when you keep on asking questions, there will be about 30-40 questions in the chat box, and it will be definitely, I will not be able to see all of them. Right, and with that note, welcome all of you to the first day school of 3417. There is a small activity for you to get started. Can you go to this website? I am asking you a question. What device are you using to join this class today? Please type www.menti.com and this code. Let me stop sharing and present the Mentimeter. Right. Can you see? Please type www.menti.com and use this code 25113475 to see, for us to get an idea what is the device that you use to connect to this class. Yes, I can see. I think maybe you also see now there are 15 answers. There are, how many students are there in the class today? 270. Let us wait at least 100 students answer. Yes.
Code.
I will put in the chat. Can't you see it in the screen? 25113475 is the code. www.menti.com. Please don't write these lines on the screen. Whoever drew the line, can you please erase that? I can see about 142 have replied. Now there are 271 students in the class. Right. I will stop this screen, but please answer because this link is valid for a few more minutes. Please answer the question. Then at the end we can see how many of you have answered. So I'll stop this and go to the slide, but please keep on answering. Let me give an introduction to the activities that you have to do in order to complete this course. If we look at what are the main contents first, the course covers basics of flowcharts, algorithms, programming with C language, software engineering concepts, and relational database concepts. So these are the main units in this course. The continuous assessment activities include 3 lab sessions. In the activity diary, lab 1, lab 2, lab 3 are given. Lab 1 is a half a day session. Lab 2 and 3, maybe it will be more than half a day. And there is one tutor mark assignment. And that assignment will be given as small parts in the LMS. It is not just one big question given, one, maybe 2-3 questions given you to write answers. It could be, there are few components in the TMA with different deadlines, and then 1 or 2 bigger questions. At the end of the course, there is one mini project. That mini project is a program that you have to do the design and create your mini project in some programming language. We expect you to do it in C, SQL, and any web-based language that you would know. And it is assessed by a Viva. So you will have to come to a center and demonstrate what you have done. And then a lecturer or demonstrator will assess the mini project by Viva. After you get all these continuous assessment components completed, if you get more than 40% as the overall CA mark and 40% for mini project, you will be eligible to sit the final examination. Please note that mini project is very important. Even if you get 40% for the labs and the TMA and then the continuous assessment test, you still have to get more than 40% for the mini project as well. As you all know, the learning management system is at learnousl.ou.ac.lk. And when you log, at the moment, I know all of you have access to the faculty course. Most of the new students may have access to EEX3417 course as well. And the course synopsis is given in the LMS. If we look at your time investment, this course is designed so that it will take about 197.25 hours for a student to successfully complete this course. There are 27 self-study sessions in the book. So for each self-study session, we allocate 2 hours for theoretical study and 3 hours for independent work. So, and there are 5-day schools of 2 hours each. Then it's again 2 hours and 9 hours to do 3 lab sessions and 15 hours to do mini project. For the lab sessions and the mini project and the self-study sessions, there are independent learning hours that have been allocated. That number comes to about 92.5. Out of the whole amount of time, about 16.75 hours are allocated for assessment. So this is a 4-credit course. A 4-credit course is roughly about 200 hours of time commitment. So please make sure that you allocate this amount of time to study this course in order to complete it successfully. So what do we expect you to know at the end of the course? When we start something, we need to know what is the goal that we are going to achieve. There are several learning outcomes that we expect a student to know by the end of the course. So these are the learning outcomes that is listed for this course. This is available in the course synopsis and in the LMS as well. First one, demonstrate the ability to gather requirements to develop a software solution. Software development starts with finding requirements. So that is a skill that we expect you to develop. Then describe an algorithmic solution to a problem using pseudocode and flowchart. I will explain in the today's day school what is pseudocode and how to draw flowcharts. Why we learn pseudocode and flowchart is to use it so that in order to describe an algorithmic solution for a problem. So after we design a solution, describe a solution, then you may need to design it. There are structured design principles and object-oriented design principles. So in this course, we will briefly touch on both structured design principles and object-oriented design principles. We are not going into deep of any of that. You will get a basic understanding of both design principles. Then once you design your solution to the problem, you should be able to write that in a programming language. For that purpose, we use C language. And that is why you need to learn C programming to write, test, and debug means finding the faults and fixing it again, and then deploy your computer program. Any software solution may have some data to be stored. When you discuss about data to be stored, you need to know database management systems. Database management systems have would give a like the theoretical background on how to represent data and how to model data in a way that it can be stored and retrieved easily. We will also briefly touch on security threats for software and basic techniques to make software secure. So you should be able to describe what they are. And other than C language, you should be able to use numerical computing software for engineering problem solving. That is the simulators that you may have to use in any of the fields that you are in, whether it is civil, electrical, mechanical, whatever the field you are in, you will have to use this numerical computing software for problem solving. So though these are the learning outcomes that is expected for you to know by the end of the course. Then during the lab sessions, you will be asked to design an algorithm using a flowchart for given problem. In this today's class, we will discuss actually what is an algorithm and how to write algorithms so that you will use it in the lab session. Once you get the solution done with the algorithm, then you should be able to use the programming syntax and write that in the programming language. And for that, you have to follow coding standards, and execute it means you have to compile and run it and then fix the whatever the faults. The second lab session, a second or the third lab session is the database implementation. You will be required to create a small database using MySQL and then build a small application with the graphical user interface using a web tool, usually like PHP, so that you should be able to have the algorithm running in as a complete program. So you have the database and a user interface and whatever the problem solving part all embedded. Then about 1 hour or 2, we will give you this simulation software for you to understand how to use it. It would be similar to MATLAB, may not be MATLAB. That is for you to get used to using simulation software. So these are the lab sessions. So you must do lab 3. In the lab 3, you will get to know this database creation and the making of a application with the graphical user interface. Because when you do the mini project, we expect you to like make your program using all the knowledge that you gain during these 3 labs. So without lab 3, you will not be able to do your mini project. So if I describe what exactly is the mini project, because this course is a practical course and we will give you the mini project as soon as possible within like two weeks. And the assignment like the TMA1 and even the labs, these are all related to the mini project. In the mini project, the first step is to find a client. So if you are going to solve mini project means you are going to solve a problem. To solve a problem, somebody has to have a problem. So then the first step is to find a client, and then from the client, you have to gather requirements. You have to ask and find out what are the requirements of that to solve that problem. And once you gather the requirements, then you have to analyze the requirements. Then you go to the solution. To make a solution, you need to design, implement, and test. So all these steps makes a development of a simple software solution. And please note, don't copy. And when you copy the code, it is evident. Even maybe the very similar solution, when two students write it separately, you will be having at least the different names in the variables. But if you make even the variables and everything similar, then we will have to say that it has been copied, and the copied answers will not get any marks. These are the references that you can use to practice C program and the software engineering theory. And there are interactive tools in this programs.com, this site. I didn't see C programs, but Java, Python, and other programming languages are there. Right. Let us move on to the session 1. So before that, let me ask if there are any questions. I see there are 19 in chat, but now LMS, I'm not going to answer these questions about LMS. All new students would have access to LMS. The re-registering students will get the access only after you register. Right? So in the session 1, I hope you have got your books, right? As I said, there are 27 sessions. In the first session, these are the sections that are covered. And let us go through them one by one. What is the importance of software system for engineers? Now, those students who are participating today, I know you are not students in computer engineering. There may be few in computer engineering, but the majority will be in from other fields like civil engineering, textile, mechanical, many different fields. Why is software systems have become so important for any engineer? Because software has become an invisible thread, tying all fields of studies together. When you go to work as an engineer, you may need to know this process of software development for mainly these 3 things. You maybe have to create your own simple program, especially even before you graduate. When you are doing your final year projects, 90% of your projects may need a small, at least one simple program to be written, and you will need it to write your own program. And when you go to work as an engineer, then you will be in the decision making stage, whether to buy or develop software in-house, and making this decision like uh, what to do. And then in your workplace, you may have to automate the current manual systems. To do all this, you need to know at least the basics of software development. So that is why this course has been made compulsory for all engineering students. So if you are in civil engineering, now these designs, now it's done in with software systems. First done in all design, like textile engineering, even electronic and communication engineering, it's first done with software systems, and then only you will be going for the product development. Say for electrical engineering, mechatronic engineering, mechanical engineering, all fields will be having something to do with software systems. This is another activity, simple activity for you. Please go to the same place, www.menti.com, the same code, and enter like which field you are in. Let me present that slide. what is your specialization? I think some students have already answered. Wait. Can you go to this second slide? What is your specialization? It's the same code. Let me type it to 511 3475 is the code. And the web address is w.menti.com. Let us see how. Okay, there are many computer engineering students. Civil, electrical, electronic, textile, mechanical, mechatronics. So we have students from all the fields. Sorry, I think I have been speaking with muting. What is the software system? A software system is a set of interrelated components arranged in an organized way to achieve a specific goal. In here, computer program means a set of instructions that tells computer hardware what to do. And then there are configuration software. It's a set of computer programs perform a specific task. It's important part of any software system, as you can't have only the programs without this configuring software. On top of that, there is system documentation and user documentation. As you know, a computer program, you can see the code, but it's hard to see it as any tangible product. What you will see is the documentation. That is why it is very important in software development that the documentation are there. So when we go through the course, you will see what are the documentation that you will have to do from the step 1 until the last step. There are many types of software. So this is a classification of current software. We have application software, what the user would see. And then we have system software. Under system software, we have operating systems, utility software, device drivers. And the system software is the link between the hardware device and the application software that the user see. For example, this PowerPoint presentation is made on Microsoft PowerPoint. That is the application software. How do I use this? Is for that the system software helps me to have the connection with the hardware device. These are few examples of software systems. when we talk about programming languages, there are many program language compilers and interpreters. We say for C language, we have a compiler. For Python, we have an interpreter. There is a difference. We will, it's written in the book, what is the difference. And when it comes to system software, it's a special type of a computer program that works either between application program and hardware or between user and hardware. And there are few categories like operating system. Now, I am using Microsoft operating system, but there are other operating systems, Linux, Unix, Apple, uh, Ubuntu. There are many types of operating systems. So these are operating system is a very important part or the main or the core of the system software. And then we have device drivers, which also comes under system software. If you have a printer, a keyboard, monitor, mouse, how are they connected to the main computer? The CPU is with the device driver. Then utility software. We need to back up our programs. We need to clean the hard disk. Then there are security uh, software that to get our programs secure. So these we call utility software. Then we have firmware, where we can embed programs into the chips. So like mechanical, computer, electrical students are having a second year course called microprocessors and interfacing. So when you are going to do that kind of courses, you will understand better that what how to use firmware. So there are these programs embedded into the chip itself. When we come to application software, there are three types there also, or we can say mainly two. For general use, like Microsoft Word, the accounting software like Excel, and database management system, project management software, this is for general use. Anybody or everybody will be using this software for their general use. And then there are specific applications like MATLAB. So the clerks or the data entry operators in the university, they are not using MATLAB, right? Like people like you, the engineers, will be using MATLAB for problem solving. And then there are design software like AutoCAD. So that's a specific application only used by a set of specific uh, jobs, not for general use. But the general use software for everybody, even who engineers or any business uh, business entity, anybody for day-to-day work, they will be using this general software. When we come to software licensing, because software is not free all the time. There are open source software where we say the source code or how it is written is freely available. Then there's closed software, the source is not freely available. So that is why there is this software licensing is there. So we need to know what software licensing is, because it's the licensing gives the legally valid guidelines for the use and distribution of software. The PowerPoint presentation program that I am using is Microsoft. So Microsoft PowerPoint is not free. It comes with a license. But then there is a similar software that is free with open source. This is when you talk about copyright. Copyright is a right given to authors or creators of works to control the copying or the exploitation of their work by others. So it is necessary because if we start copying and using it without paying the fee, then the creator will not get any uh, money or any funding. But there are free and open source software also where they charge for service, but they give the software free. There are many licensing types. Here we say there are topmost like trade secrets where everything is kept as a secret and the general public is not disclosed of anything. Then there are proprietary software like Microsoft PowerPoint, Microsoft Excel, etc. They are exclusive property of the developers or the publishers. We can't copy and use it. We have to buy the license. Then there's freeware and shareware premium. Those software are free of charge, but they don't give the source code for us to make any changes, but we can use it. Then copyleft false. False means free and open source software. It allows unlimited freedom to use, study, and privately modify the software. This general public license is the first copyleft license. And then there's permissive force, that is another type of free and open source software. It allows user to use, study, and even modify the software. And it include minimum requirements on redistribution. Your online class is hosted in Moodle. Now, Moodle is a open source software. There is a community or many people that make plugins and developments to Moodle. So it's a very good example, of this kind of a software. And then there could be public domain software without any ownership. I hope you understood. Can somebody, is there any questions regarding this? Shall I stop for a minute?
Excuse
Yes,
me, madam.
yes.
මම ප්‍රශ්නයක් අහන්න අහන්නද මේ අර ෆර්ම්වෙයාර් කියලා කියන්නේ අර මේ කම්පියුටර් වල BIOS වගේ තියෙන ඒ වගේ දෙයක්ද?
When a setup, so setup and so other things you can embed into the chip itself. Then hard. Even neural networks can be in firmware. Right? Okay. Now, let's go to the session 2. All of these first few sessions are actually introduction to many aspects of software development but it is not going into depth. In session 2, we will learn about computer programs. A computer program. What is a computer program? It is a collection of instructions that describe a task or set of tasks to be carried out by a computer. How does program work? We give instructions to computers by means of programs. Then the programs translate those instructions from a human readable format to a computer readable format. And why do we need programming languages? That is in order to develop programs. Almost every program performs 3 basic tasks. They manipulate data, they will perform operations, and provide results. So whatever you do, these three basic tasks are the things that we mainly expect from any program. There would be data. We will expect to manipulate this data and perform some operation on that data and then provide the results. For example, this registration software, there will be a lot of student data we collect and put it into the system and then give you courses on the MIS. So once the data is given, then there will be operations like uh, adding, deleting, updating, etc. We have to keep your data records updated. So every year the registration is done. If you want, if a student need to update the address or the change the center, change the field, those operations can be done. And then as a result, after we can get a list of registered students. And with that list, we work, right? We will give that list to the learning management system and upload. So like that is how the results are used. Please don't disturb the class because it is being recorded, and we will upload the recording. Don't disturb it. Otherwise, all these noises you make will be get recorded. If we look at briefly at the history of programming languages, at the beginning, computer programs were written in the actual language of the computer, that is the machine language. However, now the history has changed. A lot of developments have been done, and the programmers can write programs in programming languages in higher level. So it is relatively easy and learn, and mainly it is error free. We'll look at a few examples also. The languages are categorized as machine languages, which is the basic, the primitive form, the first type of languages that we use. And then the assembly language, it is bit higher than the machine language, but in no way it is comparable to high level languages like C that we use today. We'll look at an example. The machine language work with ones and zeros, that is binary digits. It is directly related to an electrical state of a switch. If this switch is on, the current flows and then we can get 1. If the switch is open and the current does not flow, then we say it's off, the switch is off, and we get a 0. So all this machine code is in very early computers. When the computers were first invented, that is how the programming was done in computers using this 1 and 0. Then we moved into assembly language. And if you look at the other side, you will see this 1 and 0 are written in hex here. Now move into EEX, that registry. So these sentences are written in hex language. Now 210A, it means instead of writing 21, you can write with binary, but it is written in the hex so that it's easier to show. This is a simple code in machine language. So if we convert it to assembly language, it would look like this. This is simpler than using only ones and zeros, but not that easy, right? But it's more readable. When you can say A for add, CMP for compare, MUL for multiply. So a program can be written, a simple programs can be written. I think you can see it is bit or more easier than the binary only. The programmer who uses an assembly language requires a translator to convert his or her assembly language program into machine language, because finally, what does the hardware understand? The hardware inside the computer understand only the machine language. So even if you write your program in assembly, you need the translator in between to convert what you write in assembly to machine language. This same program, let's see how it looks like in C. Can you see? How many lines are there? 1, 2, 3, 4, 5. With 5 lines, this is the same thing that has been written in assembly and in machine language. So can you see the difference? As you can see, the distinct features of any high level language is that there is an extensive vocabulary of words, symbols, and sentences. And they are problem oriented so that the programmer will be able to work independent of the machine. So the programmer can concentrate on the problem without thinking of the machine. Otherwise, you will not be able to, as a programmer, think of your problem solving. You will have to spend so much time on finding errors, mistakes, and trying to struggle with that machine coding. In high-level languages, there is always a set of rules. Even in any language, say Sinhalese or English or Tamil, there is a set of rules how to use the language. So the computing language also have a list of rules, like rules of grammar in other spoken languages. This is a family tree of programming languages. This is in the slide set, so I'm not going to go into details. You can see started with assembly, come down, and you can see the new languages like Ruby, Dylan, and then somewhere C and Python will also be there. Say C is here in the far left corner. C, C++, Java. I think these are the languages that you must have heard of. In the middle, it's actually the scientific languages, like which starts from Fortran. And then the languages that in the right hand, you will see SQL, DBase. Now, these were the languages that was used to create, and query databases. So hope you got a brief understanding of the evolution of programming languages. When we talk about programming paradigms, a paradigm is a typical example of a pattern of something. We'll see what are the paradigms in programming. We see imperative programming. That's based on sequence of explicit commands. Then we'll go into details in a bit. Then we talk about declarative programming, where we have functional and object-oriented. So functional are based on functions and abstractions. So we hide the details. The user or the programmer can see some abstract functions where what he can use to solve the program. And then there is logic programs, and then data management languages like SQL. And now there is a new data management language called NoSQL. And we come to object oriented. This is based on objects with properties and method. So in your course, we will look at briefly at functional design and object oriented design. So you will get a understanding of both. We will not go on to logic. When you do AI and machine languages, machine learning, you will be using logic. And data management language, MySQL, we will briefly use MySQL, and we will not be doing anything on this parallel programming. So as programming paradigms, so these are the 4 types of programming paradigms that we have today. If we look at a simple software system, we have software mainly and the documentation. When it comes to software, one big software system would be consisting of small modules. M stands for modules. And files. File is there to get all this data into. So the data is one integral part of any software system. So the data will be in the files, and then there are the algorithms, the UI, all these are in this computer programs. Modules will consist of many small computer programs. And the documentation will consist of user documentation, testing documentation, system documentation. So there are several types of documentation in each, which relates to each part of the software development phases. Why I'm stressing is that at this stage, it is very important that you understand that software is not only a program, it has an integral part of databases or data files, as well as documentation that describe what this software is and what it does. So far we looked at only what was given in sessions 1 and 2, and when it comes to session 3, it gives an introduction on the software life cycle. So we look at, when we go into the session, without describing here, I will go to the session. What is software engineering? We have in IEEE, in this standard, it's written, the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. That is the application of engineering to software is called software engineering. And the study of approaches as given in 1. So that is how IEEE standard defines software engineering. This is the product life cycle. So any product, say a mechanical product or a bridge, it could be a product in civil engineering or a textile product. In general, this is the product life cycle. First, you have the concept and the feasibility study. For any product to develop, you have to identify a marketing opportunity, or there must be a need in the organization. Now, everything we do is not for marketing. No, we need the student information system for the university. That's the need of the organization. We need salary calculation system. That is not to market. That is not because of the marketing opportunity. That is because that's an organizational need. We need to run the organization. That is the first thing in any product. Then the product developer have to find out the requirements. Can it be done? And if so, what exactly the product will do? And the quality needed for it to be viable. Viable means practical. That is the requirement definition. Once the product developer find out how it can be done, then the product developer will give it for the designer. At the high level design, you agree on what functions the product is to perform. What are the key elements and the expected quality? That's the high level design. After the high level design, you come to the low level design where elements are divided down into very basic components where the functional requirements and the quality requirements are also defined relative to the requirements of the element or the subsystem. Then a prototype is made. That's a simple model of the final product built and tested. And then you go for manufacture. And after manufacturing, you can market many copies of the item. After you market, then comes the maintenance stage. After anything is being done, say if it is going to last for 5 years, 10 years, 15 years, there will be some, say it is a motor car, a van, anything, the maintenance has to be done. And any product will not be there forever. So there will be a time that you will have to decommission it. We call it obsolescence and decommissioning. The current product is decommissioned and the support is stopped. That is, then the life cycle has to start a new product. This we say the typical product life cycle. If of a hardware means not only computer hardware, it could be a mechanical product as well. Hardware, we say, is designed once and then many copies are manufactured. But these copies may not be identical and they may be faulty as well. However, if you make a software product, all copies are identical. And similarly, failures could be design failures and they would be in all these copies as well. When there is a fault to be rectified, we call it a patch, and the software is automatically upgraded. So this is the difference between the software and the hardware. Similarly, there is a software life cycle as well, software development life cycle, very similar to product life cycle with very minor deviation. Here also, we have to find a marketing opportunity or an organizational need and find the requirements. Agree on what functions the system to perform. And in software development, we emphasize a lot or focus a lot on requirement gathering, capture and analysis. You have to write a detailed document, including functional requirements and non-functional requirements on what the user, or the user means the customer, really wants from that solution. Then the high-level design, how will the system meet this requirement? Then the implementation, individual modules are written in a source code, compiled and integrated. And then testing, first individual models are tested and then they are integrated and tested as a system as a whole. You will have a trial, the complete system operated in a real environment to validate whether it meets the original requirements. Then the deployment, Deployment means release to the customer or go and install it on a site. And then operation and maintenance. The system may need to have faults corrected, be adapted to new circumstances, and perform new functions. And as any product, the software also, there's a step called obsolescence where you will have to retire and replace it. So that's a general overview of software development. And there is a special task that comes in software development, verification and validation. What is verification? In verification, we are trying to see, are we building the product right? Here we have to make sure that the products have this requirement, they comply to requirement document, design documents, and all these things we will be learning within this course. How to make the design document. ER diagram means entity relation diagram is to design a database, and the test cases. So all these we will be doing in this course. And then when it comes to validation, validation means the final end product. Whether the final end product is what the user expected to be built. So there are techniques used for validation like functional testing. There are different testing, system testing. So these testing have to be done. In verification also, there are techniques to be used, like we call them review, inspection, walkthrough, etc. So those are techniques to make sure the verification. Verification means whether the product is being correctly built. Next, we will come to requirement elicitation. Can somebody tell me why is it necessary that we need to do requirement elicitation, or what do you understand by requirement elicitation? Can somebody unmute and say? Yes. What is meant by requirement elicitation? Elicit means capture or gather. What do we really do in requirement elicitation? Yes.
මැඩම් දැන් මේ දැන් software එක අවශ්‍ය වෙලා තියෙන customer එක සාකච්ඡා කරනවා වගේ දෙයක් නේද වෙන්නේ තෙන්දී?
ඒක mainly සාකච්ඡා කරන එකට අපි කියන්න පුළුවන් that you interview the customer one way. තව මොන විදියටද හොයාගන්න පුළුවන් requirements? That's the main. What you said is very correct. That's the main method that you will use to get the requirements of the actual client. Any other suggestion?
අපිට Google form එකක් වගේ fill කරන්න දීලා කට්ටියකින් ගන්න පුළුවන් idea එක ගැන සාමාන්‍යයෙන්.
Yes, that we call using a questionnaire. For the clients, we can give a questionnaire and get it filled. Any more ideas? What is mostly done is go and interview, go and speak to the clients in the site. Then the questionnaire method is also done. Can you think of something as just one more? Very
By making a prototype and asking them if that's what they need.
Yes, that is after you get some idea, you can make a prototype, show it to the customer and ask whether is this what you need. And the other thing is you can go to that place, for example, say the passport issuing office or the NIC issuing office or pharmaceutical company. You can go and observe the process. And then you can design how you can automate it. That is, not everything can be observed, but even the student registration for Open University MIS can be observed. So there may be some problems that you may not be able to observe, that you will have to ask and get the questionnaires filled, get the prototypes done. Prototypes are very useful if the client cannot articulate, if they cannot describe it very well. Say the client also may not know what they need. And then you as the developer also can't think of what would they need. They will say we need this end product, but other features like how the data entry screens should be done, those things, even the customer may not be able to tell. So then it is good that you can make a prototype and show it. Sorry, right. Now this requirement, properly getting the requirements is a very important aspect in the development. So this is a very famous cartoon. It says, this is now the say, if you look at the first picture, it says how the customer explained it. The customer explained now he wants this product. The second one say how the project leader understood it and how the analyst designed it. The third one, how the programmer wrote it, but how the business consultant described it. This is how the marketing and the business consultant showed it to the customer. And can you see there's nothing, how the project was documented, it's almost empty. And when you look at what operations installed, there's actually nothing much. But when it goes for billing, how the customer was billed, it's like an escalator, right? And when it comes to support, it says how it was supported. There's nothing to support as well. But finally, if you really looked into it, it says what the customer really needed. So this is a very famous cartoon that is with the software developers to show that getting the requirements correct is very important, and to get them documented and get it, show it to the customer and get their signature on the agreement. So the both parties, the designers, developers, and the user must agree on what exactly to be developed. Otherwise, since that is why we say software is intangible. You can't see. When you build a house, when it is half built, somebody can see it. Any product, when you build at least the parts, you can see it. But when you start building a software system, you build it module by module until the end. You can't really see what it would look like or what it would be finally look like. So when we come to software development life cycle, in software engineering theory, there are many types of life cycles. Waterfall life cycle model is the first life cycle model, and it has same stages or the steps as the software development life cycle. Requirement analysis, design, construction. Construction means write in the programs. This is where the write in the programs come. Then you have to do testing. Deployment is installing the software at the customer side. And finally, operations and maintenance. Going each of these steps like a waterfall is the waterfall model. There are many drawbacks in this model. main thing is the requirements change. When the development is being done halfway, the client will come and say, there is something different that I want. The use ID, it was agreed to have 5 digits, but it needs to be 7 digits. And then there may be a government circular, a new tax is included. So then you have to include that new tax. Like that, requirements change. So it is very difficult to have concrete requirement document and work on it, because if it takes like 6 months to finish it, or even 1 year, by the end of 1 year, there would have been many changes included to each of these phases. Therefore, currently, a waterfall life cycle method is used only if it's a very simple problem and if the requirements are very very clearly articulated. Otherwise, there are other methods like we call them agile methods, spiral. So there are other software development process models. When you go through the book, you will see about another 4 or 5 software lifecycle models. There is one called prototyping model. If it is difficult for customer to articulate what exactly needed, and if there are a lot of, say, graphical user interfaces included, then it is better to go for prototyping model. And then these days in the software industry, it is the agile method that is mostly used. In agile method, what happens is you get one part of the, without looking at the whole system, you divide it into small modules, and for each small modules, you go through requirement design, construction, testing, deploy it to customer, and then do the second module. So it goes on a cycle. So like every month, maybe there would be some product to be delivered. So that is the agile model. As we discussed, say a prototype is not the full program with all the functionalities. So in a house, we make a prototype like this, but it is not made of brick and or cement and everything. That's for only for user to see. Software is also like that. The user has to understand the prototype is only the graphical user interface. The functionalities inside is not there. So when you show a prototype to the customer may think now the program is already done and it is there, but it's only the surface, right? But you are showing as a prototype. So you have to make the customer understand that's not the full system being made. So before we come to the next section on algorithms, your mini project, we expect you to do in the waterfall model in this traditional software development life cycle. Since we are learning and doing, we will first do the requirement analysis, then the design, then the program, then testing. And so mini project will be the final product. Now, algorithm is in the design part of the software development. So in session 4, you have these subtopics: what is an algorithm and how to represent algorithms and non-uniqueness of algorithms. So let me go into that. Before going into the theory, let me ask you to do a simple example. Then you can also be active here. For example, if you are to make a cup of tea, what do you do? Can you unmute and say? Let me get it in a, okay. Can you tell me what is the first step that you have to do? So I got into this mode so I can write whatever you tell me. What should we do first?
Boil water.
Okay. Next.
Mix tea leaves and boiled water together.
Wait, mix tea leaves and boiled water together. Yes. Next,
Add sugar.
add sugar, right? And maybe add more tea. Or you can say add milk. So like that, step by step, you are telling somebody. Say if it is somebody who does not know how to make a cup of tea, step by step, you have to say, okay, do this, next do this. So like algorithm is the way we tell a computer what to do. Before writing any program, you will have to write it in an algorithm as the way you solve the problem. Step by step like this. Do you get it? Is it clear?
Yes.
Right. Okay. We'll go to the presentation mode. So we say algorithm is a step-by-step instruction for solving a problem to achieve a result. So that is the definition of an algorithm. And algorithms are especially important to computers because computers are general purpose machines for solving problems. So the machine need to be given step-by-step instructions. When we discuss about algorithms, you must remember these 5. Now, these are the 5 properties of an algorithm. It is well ordered. It must have unambiguous operation. Unambiguous means not ambiguous, so that it's clearly understood by the computer. And there has to be computable operations. There can't be like, let me think of an example, uncomputable operation, because it has to be something that can be done and it should produce a result and it should finish in a finite amount of time. Why is it important? Any algorithm should finish, otherwise it will indefinitely working. For example, say for computer, you say print all the integers more than number 2. Will it stop? When will it stop? If you give, it will not stop, no? Because 2, 3, it will go to infinity. I mean, there is no way that it can stop. It can, even it will fill the screen, it will go on printing, right? But the algorithms you write must finish within a finite amount of time. For that, you have to make sure there are terminating conditions. Right. Algorithms are shown with a flowchart or pseudocode. Can you remember I said we are going to learn flowcharting and pseudocode. So flowchart, there are 2 videos done by Mr. Neil separately, how to write in pseudocode and how to draw flowchart. I will briefly explain also. In flowchart, there are these symbols. First is the process is shown by a rectangle, a sub-process. Another simple process with a rectangle with 2 lines in left and right. Not exactly an ellipse, but similar to ellipse, we have this symbol for terminators. Start and the end of any algorithm, we have to show with this terminator symbol. this is the decision. It's with the rhombus, we can say with is A greater than 6, yes, you go to the right, or false. It doesn't matter actually which way the arrow goes. It could be any side. Now the first input arrow is coming into the decision, but output arrows, there should be two output arrows, one for true, false, or you can even say yes or no. And then input A, output A, like input and output in this slightly slanted rectangle. So these are the visual language or the flow charting symbols that we may use to write an algorithm. The other way is a pseudocode. Pseudocode means it's a semi-structured English-like language. Here, all these we can write, say, start. And then, like the way you said how to make a cup of tea, you can write all the step-by-step instructions. And if there is a comparison to be made, say you want to calculate the grade of your marks, you start you can say input the students marks for EEX3417 final marks, and then you can say enter maybe continuous assessment marks, and then you have to say if continuous assessment marks more than 40, then you can say the student will have the eligibility to sit the final. So that is where the comparison comes. And where does the repetition come? Now in that algorithm, we worked it out for only one student. Now there are 263 students in this class. So if you want to do it 263 times, then you have to repeat that same thing 263 times. That is where repetition is used. For that, there is a different construct, and there are keywords how to say that. Repeat until, while, do while, and these we call loops also. There are four ways that we can write a repetition. So both these methods we can use to write an algorithm. So this is what we did. So you can even elaborate it more. Like put the tea bag in a cup, fill the kettle with water, boil the water in the kettle. Now, when we say that, say to a robot, then when we say, we can't really say fill with water, right? We have to say the quantity of the water. And when we say boil the water, now we have to stop. So these are the unambiguous instructions that you have to give. Like if you can't just say add milk to the cup, you will have to say like 2 teaspoons of milk, like maybe 1 teaspoon of sugar. These are the unambiguous instruction. When you say just add milk, then it is ambiguous, not clear, right? So think of it when you start writing algorithm. Here is another example of adding two numbers. Now you can see the algorithm here. Start, read the first number, read the second number, then add the two numbers, print or display the total, and stop. And how do you write it in the flow chart? Can you see start, read A, read B. That's the next sentence. Then add A and B and put the total in C. Now these we call variables. If you now in flow charting and pseudocode, we don't talk about variables, but when we go to work in a programming languages, we use these variables which we use to name a memory location in the computer. So thinking of a memory location in computer, we say, okay, read the first number, read B, what is the value of the B, then get the total into another place and write C and then end. Please remember, you always have to have a start and then end. And the symbol name is terminator, input. This is the process. Write C is the output and the terminator. Is this clear? So when you come to the first lab, you will be given some simple questions where you will have to write the algorithm. For the assignment also, we will give you a small problem where you will have to write an algorithm. And there are, I think, self-assessment questions in the book as well. Any questions from this up to here? This is one of the most important part now. I told about application software, operating systems, and licensing. And I said there are function-oriented design and object-oriented design. Now these are all introductory parts for the software development. And then the product life cycle, what is the difference between product hardware and software, and what is the software development life cycle. So these, you see, they are like the background knowledge, but this writing the algorithm is the main task that you will have to do, and where you will get the questions. So you should be able to write a clear algorithm. So up to here, is there any question that you would like to ask? No. Okay.
madam.
Yes.
මේ ඇල්ගොරිතම් එකක් ලියනකොට කැපිටල් වලින් හරි සිම්පල් වලින් හරි අනිවාර්යෙන් පටන් ගන්න ඕනේ කියලා එහෙම නීතියක් මොකක් හරි තියෙනවද?
නෑ එහෙම ප්‍රශ්නයක් නෑ. Simple ලිව්වට කමන්නේ අපි සාමාන්‍යයෙන් since we usually write a sentence with the capital letter, we write with capital. Otherwise, there is no hard and fast rule. Now in the pseudocode,
සාමාන්‍යයෙන් දැන් මොකක් හරි ප්‍රශ්නයකට ආන්සර් එකක් මෙහෙම
ප්‍රශ්නයකට උත්තරේ ලියනකොට මේක simple ලිව්වයි කියලා ඒක කමක් නෑ. ඉතින් ලකුණු කපන්නේ නෑ. It's readable. අපි අර
දැන් බලන්න මේ දැන් ඇල්ගොරිතම් එකක් අපි ලිව්වට පස්සේ ඒක දැන් ආන්සර් එකේ තියෙන එකම නැතුව දැන් අපේ සාමාන්‍යයෙන් අපිට හිතන එක ලියන්න එහෙම ප්‍රශ්නයක් නැහැ. තව එක්කෙනෙක් ලියපු එකයි මගේ එකයි වෙනස් වුණා කියලා මේ උමුණා දෙනා ලියවිලා තියෙන්නේ.
ඔව් ඒක ප්‍රශ්නයක් නෑ. ඒකට මං එන්නම්. ඒ කියන්නේ එකම දෙයට algorithms කීපයක් තියෙන්න පුළුවන්. There could be many algorithms. If the next one is non-uniqueness of algorithms. Algorithms are not unique. What does it mean? There are more than one way to write the solution for any given problem. This is a very good example. You are given, say, 10 numbers to sort in the ascending order or the descending order. There are so many sorting methods. There are how many sorting methods are there? 5 sorting methods to sort, say, 10 numbers in the ascending order. So what it is quite correct. And when we give marks, we will not be exactly looking at like whether you write these things exactly similar as the model answer. You can get the full marks with a different way, giving the answer in a different way. There will be a general guideline, but you can write it in a different way. Can you see the pseudocode also? Can you check? Start, it's like the flow chart, all the steps in the flow chart, right? Start, read A, read B, and this we call the assignment operation. A plus B is assigned to C. And then we print C and stop. Yes. Any more questions? Anybody else having any more questions? Right, let me move on. So only very few more slides now. You can stop me. So now since it's very good that you asked that question, so that the others also could understand what this means, non-uniqueness of algorithms. This is the final section, just a brief introduction to programming in C. In the second day school, tomorrow's day school, you will get to know more about C language. Though if you are joining with the computer, then you can have the compiler ready. I mean, there are compilers in the web also where you can type then and there and see. Right. So C is considered as a high-level programming language. It is very close to English and closer to human language. So that is why it is easy to read and write. This is the book that we have recommended you, the C programming language. This is available in the web. It's a free book with this Dennis M. Ritchie, the author. Since the computer can understand only the machine language, a program that is written in C needs to be translated into machine language before executing. How does it work? We write instructions in the C language, and we need the program called editor to write this. So we get the editor, we write our program, and we save it. And then we do this task called compile. When we go to this, we use code blocks, or there are code blocks is what we use in the lab, but there are in the internet many free C compilers, and the editor is also there. Once you write in the editor, save the file, then you have to compile it. Compile means convert what you have written, the source code, into object code. And then there is another task in between called link. That is translate the object file into an executable program. That means that we are converting it to machine code. That is converting your C language compiled into object code into 1.0 machine code, which works at 1.0, and then you run the program, and then only you can see the output. In all our C compile that comes with the compiler, we call this IDE, is Integrated Development Environment. Integrated Development Environment has integrated editor, compiler, and linker into a single software system. So the Visual Studio, Eclipse, now these are examples of IDEs. And code blocks, if you have gone to the learning management system, you have seen that we are using the IDE called the code blocks to do our practicals. So this is what you do when we say you write the program. Is that clear?
Yes, madam.
All right. So in the next day school, I will show this first, the skeleton of what is inside. When you write a simple C program, you may see in C code the first sentence, include stdio.h. It is a preprocessor command which tells the C compiler to include a library. This stdio.h and stdlib.h, etc. are we call files that are needed to run this program. Because you will understand when you go on writing, you don't have to write everything every time you want to make a program. There are certain things like output something into the screen that can be reused. So that is the use of these libraries that we get with include command. So already, if you want to output something to the screen or get input from a keyboard, there are certain functions that need to be done. These functions are already written and saved somewhere, which we call these library files. And these files we have to include in our program if we are going to use it. That is the meaning of this includes stdioh. Then int main, I will not going to explain more. This is the main function where the program begins. Instead of saying start, now if we write in pseudocode or flowchart, how do we tell anybody that we are going to start? We write the word start. But in C language, main function, we have to say main with these two empty brackets. And the curly bracket, it says start of a block of instruction. And there should be a closing curly brackets at the end to say end of block of instruction. In any program code, there will be comments. Comments means explaining what this program does. My first program in C is just a comment that the author has written to tell you this is my first program in C. It is not executed. It means now this is not going to convert it into machine language. It will be just be there in the code. This is only for humans to understand the code. Now, machine language does not have anything to do with this. There is a symbol to show that it's a command. This slant and the star. Again, it has to close with another star and a slant. That is how you describe a command. The only executable command here is this printf. Printf is a keyword in C language. Printf means print the string given within these brackets within inverted commas. So it will print hello world, and everything has a meaning. This n and this backward slash means after you print hello world, the cursor or the position of the screen, it will go down. If you print hello world 2 times, the next hello world will come after that. Otherwise, the next thing that comes on the screen will be printed on the same place. That is why we have this backslash and n. It means the cursor will go a little further. And then return 0 means finish the function. In this case, the function is main. So usually this we say return, finish the function. This is at the moment, this is not very usable. And then you have to understand why this int is there before main. This we will come into later because in C language, there are several data types. Int for integer int, and then there is character, string. Now, hello world, this is given as a string within these two inverted commas. So those things we will discuss later. So this is for you to go home and understand what a simple C program is. there are online compilers. So you can use the C programming online compiler here in this one. This slide set is given in the LMS, and actually we can, for the repeating students, we can upload the slide set in the faculty common course as well, right? This is what I said, variable. A variable is a very important thing when it comes to programming. That is the name given to a memory location that holds a value that can be changed. A variable in C language must be given a type. You have to say which type is the variable. Why we say is now there are some languages that don't have variable types, but C language has few defined types, like char is for character, can hold one character in a variable of char. Int is used to hold an integer. Float is used to hold a floating value, means say a decimal value, 10.5. Now 10.5, if you say in int, then that 0.5 will be cut off. Only 10 will be there. So if you need to have these decimals, you have to use float. Double is for a larger number than int. And void is mean there is no type. If we have void in the this here, instead of int main, we could have written void main. If we say void main, then you don't have to have this return 0. Now, because it's an integer function, you have to return something, and you say return 0. You will see the meanings of these later when you start writing the programs. And there are several rules. Now, one student asked me, when you are writing pseudocode, whether you have to write with the capital letter. In pseudocode, no. But when it comes to C language, you must not start with a digit. You can start with any alphabetical, any letter in the alphabet, but not with a digit. Inside the variable name, there can be digits and underscore, not other special symbols like hash and @ but underscore you can use in the name of the variable. In a variable name, you can't use blanks or spaces, and you can't use keywords. There is a set of words in C language that have been named as keywords. Now you saw printf. Here, printf is a keyword. Main is a keyword. Int is a keyword. Return is a keyword. Include is a keyword. Now those keywords cannot be used as a variable. You can't have a variable named main. It has to be, you can say main1 or main2, main underscore s, something like that, but not the exact keyword. And it is case sensitive. So generally, lowercase letters are used. So capital letters are not used when writing C language, programs in C language, because it is case sensitive. For example, if you write my total with capital M, and again you are going to use my total with simple m, the C language will think these are two variables and it will give an error. So that is what it means, case sensitive. Now these words like main, you can't write with capital. So you have to see what all these words you have to write in simple when you're going to compile it. right? So if we translate our algorithm to C code, this is how it would look like. See the flow in the left hand side, you can see how the flow chart look like, how the pseudocode look like. And if you translate it to C, can you see how it look like? You have int main, the start, and the variables that we are going to use, A, B, C, we have defined this integer type, int A, B, C. And then we need a number to be input by the user. So we can say printf. Printf is a keyword for printing to the monitor, the screen. We say enter a number. Scanf is another keyword. Scanf is to get the keyboard input. Keyboard input to the variable A. That is what is written, and it should be a number. Now this D and the percentage sign means we are expecting a number for variable A. Then the second print line say enter another number, and scanf is to take the keyboard input to variable B. And then there was another variable C that we defined, and to C we assign, this equal sign means assign A plus B. And printf result is, now result is just an English word, but the result, actual result is in the variable C. And if we are printing a number or getting the input as the number, we have this percentage sign and D to indicate it is a number. If it is a string or a character, then we have a different letter with the percentage sign. And then, as I said, to end the function, we have return 0, right? So this is the comparison. What I would like you to do is, before coming to tomorrow's day school, write this flowchart yourself, write it in the pseudocode, and type this in a from the web. You can get a compiler, type this and see the result. Then you are ready to continue tomorrow's day school. So that's all, and thank you. I think I will stop the recording. Mr. Neil, you can stop.
Yeah, okay.
Okay, stop the recording.